Graphs of numerical data, section 2.1 in the text. Make a stem plot for this data here. We have birth weights of in ounces of 10 babies, 103 ounces, 106 ounces, 948 ounces, so forth. And the first digit or the first two digits will be the stem. Last digit will be the leaf. So for 103 ounce baby we have stem 10, leaf 3. Next baby stem 10, leaf 6. Then we're going to have stem 4, leaf 8, and so forth. So the 103 ounce baby, so the first step is to make the stems. So the lowest stem would be for the 48 ounce baby, that'd be 4. The highest stem would be for the 117 ounce baby, that'd be stem 11. So you want to write the stems first. You have to go at least from 4 to 11. You could go a little bit past that if you want, but at least do 4 through 11. And then we can put in the leaves. So for the 103 ounce baby, we want to put a 3 in row 10. So go down to row 10 and put a 3 there. And then for the 106 ounce baby, that would be a 6 in row 10. So put a 6 here in row 10. And then the 48 ounce baby, that would be an 8 in row 4. The 96 ounce baby, that would be a 6 in row 9. The 110 ounce baby, put a 0 in row 11. 98 ounce baby, put an 8 in row 9. 104 ounce baby, put a 4 in row 10. 85 ounce baby, put in 5 in row 8. 117 ounce baby, put a 7 in row 11. A second 103 ounce baby, put a 3 in row 10. Okay, so that's basically the plot, but usually we do an additional step of putting the leaves in order from smallest to largest. The only row where the leaves are out of order are row 10. So the other rows we can just copy the way they are. We have 8 in row 4, 5 in row 8, 6 and 8 in row 9, and then in row 10 we want to put the lowest to highest, so 3, 3, 4, 6, and then row 7. And that's our stem plot. And then now if you have a large data set, sometimes they'll split the rows and they'll have for example 2 row 10s and leaves 0 for 4 through 4 would be the first row 10, so 3, 3, 4 would be the first row 10, and then leaves 5 through 9, so for example 6 would be the second row 10. So if you have a very large data set, you could do a split stem plot, and you may see some of those in the exercises and web assign. And the next thing to do is say what this tells us about the graph. So what you want to do is sort of turn the graph sideways, and I do that on the next page, because the way graphs are interpreted is sort of based on a horizontal scale. Usually the stem plots have a vertical scale, but when it comes to describing graphs, the language is sort of as if it were a horizontal scale. So what you want to do is turn the graph sideways, and this is the overall pattern. And so the longer tail is on the left. We have one main cluster. The longer tail is on the left, so this would be a skewed left graph. It also appears to be that there's an outlier of 48 ounces. That's because we have this big gap between 48 and 85. Nobody in the 50s, 60s, 70s. So that's basically the description of the graph. other possibilities that could happen, you could have a uniform graph where you have just about the same amount in each row. That would be a uniform graph, or a bimodal graph. You have two main clusters, or you could have a trimodal with three main clusters too. But in this example here, you have a bimodal graph, so you would have a bunch in the lower rows, not much in the middle, and a bunch in the higher rows. Skewed left, that's the one that matches our graph here. Symmetric, the left side is a mirror image of the right side. Skewed right, the longer tail is on the right. But anyway, the one that matches ours is skewed left, and there's one main cluster, and it's unimodal, sometimes called unimodal. This is as opposed to bimodal, and an outlier of 48 ounces. Okay, so there's other types of graphs that we can do. Another type of graph is a histogram, and for histogram, usually it's a good idea to group the data. For a histogram, you don't want too much detail in your graph, because sometimes it kind of obscures the overall pattern if you have too much detail. So typically in histogram, you group the data. And we had one baby in the 40s, we had 48 ounce baby, that one baby in the 40s, nobody in the 50s, 60s, 70s. One baby in the in the 80s, that was the 85 ounce baby. We had the two babies in the 90s, the 96 and the 98 ounce baby. Four babies between 100 and 109 ounces. Two babies 110 to 119 ounces. So you group the data, and then the number of babies in each of these intervals is called the frequency, and we'll make that the vertical scale. We have to go at least up to 4. We could go past that if you want. I went up to 5, but at least go up to 4. And then the birth weights will start in the 40s, so we have to at least start by the 40s and go up at least to the highest birth weight of 114. But I went up from 40 to 120. Okay, so the horizontal scale is for the variable. The vertical scale is the frequency. It can also be reversed. Sometimes they reverse put the frequency on the horizontal scale and the birth weight or the variable on the vertical scale. It can be done that way, but usually we'll do it the variable on the horizontal scale. Okay, so there's one baby in the 40s, so the bar goes up to 1. Nobody 50s, 60s, 70s. There's one baby in the 80s, the bar goes up to 1. There was two babies in the 90s, the 96 and the 98 ounce baby. The bar goes up to 2. 4 babies between 100 and 109, the bar goes up to 4. Two babies, 110 to 119. And that's it. That's our bar graph. So the description is pretty much the same. We have, it's skewed left. We have the one outlier here, one main cluster. So when you're describing, you don't so much describe the graph. You want to use the graph to describe the data. So usually the description will be pretty much the same, regardless of the type of the graph. The one exception, with the possible exception of a box plot, which is covered in a separate lecture. Box plot doesn't show the number of clusters. It only shows symmetry versus skewness. It loses some of the detail, but it does a very good job of showing symmetry. But except for the box plot, most graphs will pretty much give you the same description. Okay, so we could also our vertical scale here on this graph was was the frequency. Some of the exercise in the book, instead of doing frequency, they do relative frequency, or sometimes even percentage. You can convert frequency into relative frequency by dividing by the total number. So we have a total of 10 babies. So if we divide each of these by 10, 1 divided by 10 is 0.1, 0 divided by 10 is 0, and 2 divided by 10 is 0.2, 2 tenths, 4 divided by 10 is 0.4, 2 divided by 10 again, 2.2. So that gives us the relative frequencies. So we could have used, instead of using frequencies, we could have used relative frequencies, or we could have used percents. If you multiply the relative frequency by 100, that converts it into a percent. Percent means hundreds. So 0.1 times 100 is 10%, 0 times 100 is 0%, 0.2 times 100 is 20%, 0.4 times 100 is 40%. So then we could do a histogram based on relative frequency, but it's pretty much the same histogram. It's just we changed the labeling on the scale here, as is really the only thing we did differently. But otherwise, it's pretty much the same shape. And if you do percentages, this is what you get here. It's again the same shape. Okay. Another type of graph is a dot plot. For a dot plot, you make a dot for each value of the variable. In this case, it's each birth weight. So we have 48-ounce baby. I only labeled these by tens here, so we have to kind of estimate where 48 is. It's between 40 and 50, closer to 50, but that would be the 48-ounce baby. No babies in the 50s, 60s, 70s. We had an 85-ounce baby, a 96 and 98-ounce baby. We have 2 103-ounce babies. So if you have duplicate values, you want to stack the dots. And a 104-ounce baby, and see what else was a 106-ounce baby, and a 110-ounce baby, a 117-ounce baby. So again, we have this one main cluster here. We have an outlier, 48. So the description again is pretty much the same. Skewed left. The dot plots are better for a medium-sized data set, because then with a medium-sized data set you probably get more stacking, and you'll see more of a sort of gives it more shape, I guess. This is kind of like a straight line-ish type of graph with because of the smallness of the data set. So it's I would say dot plots are better for medium-sized data sets. You can also do a pie chart. We can use the same grouping we used before. One baby in the 40s, one baby in the 80s, 2 in the 90s, 4 babies between 100 and 109 ounces. And then you want to draw a circle. And I divide the circle into 10 pieces because we have 10 babies. And then there's going to be one slice for each baby. So we had one baby in the 40s, so that's one slice of the pie here. So it's one baby, 40 to 49 ounces. And then we had one baby in the 80s. There's another one slice of the pie, one baby, 80 to 89. We have 2 babies in the 90s, so that'll be 2 slices of the pie. To 99. We have 4 babies between 100 and 109, so 1, 2, 3, 4 slices of the pie. for babies. 100 to 109 ounces. And then we have 2 babies, 110 to 119. Okay, so that's the pie chart. Pie charts are not used so much in professional publications because they take up a lot of space for the amount of data, amount of information they give you. But you'll see them in popular publications, newspapers, magazines. Okay, so that concludes this presentation.